Welcome everybody. My name is Carlos Martinez. I'm very happy to be here with you in one of these webinars that we created with 3M in collaboration with 3M about working at heights. Today's webinar is about working at heights in confined spaces, which is a critical scenario for the steel industry, as you probably know. Thank you for joining again. Our guest expert today is Steve Koch. He works for 3M. He's a global application engineer. He has been working for 3M for 25 years and is currently part of the segment application engineering team responsible for utilities, upstream, oil and gas, and mining. He also is the global confined space and rescue specialist for 3M across all segments. Let me tell you something, Steve is also a firefighter, an emergency medical technician, and has over 30 years of emergency response experience, which is impressive, Steve. I think I'm handing over to you, and good luck with the audience from the steel industry.
All right, excellent. Thanks, Carlos. Welcome, everyone. It's exciting to be here today to speak to you in regards to confined space. One of the areas that I'm super passionate about, as Carlos mentioned, I do have quite a few years' experience in that, but I don't want, the biggest part of my experience is simplifying things for industry, and that's the goal. All those years of technical rescue and stuff was really exciting, but when it comes down to it, it's all about trying to make it as simple as we possibly can to make it easier to get people in and out of confined spaces. We'll start off with our standard disclaimer that many of you have actually seen. And I'll quick stop before I jump into disclaimer. Please remember you can put questions into the chat. I'm hoping that I give enough time at the end to be able to answer some questions that might come up. David Baker is also there. He'll be answering some of the questions that he's able to answer, and then we'll hold off ones that he wants to challenge me with at the end. So go ahead and again, feel free to put those into the chat. This presentation provides a general review of fall protection information, includes various 3M safety solutions. The webinar content should not be relied upon to make specific fall protection equipment or any type of personal protective equipment selection, use, and maintenance choices. Local, country, or regional regulations and guidance varies, and the responsibility for correct implementation of the fall protection program in compliance with your local, country, or regional regulations is with the employer. This presentation should not be relied upon in isolation, as the content is accompanied by additional and/or clarifying information. All right, so what are we going to talk about today? We have a number of things that are on this, and it seems like it's overwhelming. And for all practical purposes, 45 minutes to an hour is never enough time to really dive deeply into a particular topic. But as you've seen from some of from the other previous presentations done by the 3M team, it gives you enough to increase your knowledge just a little bit, and also hopefully get you to ask more questions that we can help you out with in the end. So what we're going to again cover is, confined spaces, why we enter them, and what they are. We're going to look just a little bit at regulations again, because this is a global audience and it's important for you to understand your own regulations. We're not going to get too deep into any one of those. We'll talk about some confined space roles and responsibilities, the ABCs of confined space, and I know that you've heard about the ABCs of fall protection. These are a little close to that, except for manipulated it ever so slightly. And then we're going to briefly talk about confined space entry and rescue plans. And again, we're not going to be able to get deep into all of these, but at least again, it will give you some information that hopefully will excite you about confined spaces and ask more questions. So what is a confined space? Generally speaking, a confined space is something that's partially or fully enclosed space. It meets kind of a number of different criteria. One is large enough to enter and bodily enter, so the whole body has to get into the confined space, and then work has to be performed. A lot of people get confused on what work means. Is work, chiseling out slag out of a crucible, or is it doing, knocking down soot or anything? No, it could be something as simply as inspecting. You're inspecting the weld on the vessel inside. So it doesn't have to be that physical labor that some people think of. Visually inspecting something is considered work, but it's about getting that whole body in. Typically, a confined space or enclosed space has limited or impeded openings to entry and exit. So this is not a doorway. We're not walking into a doorway. We're going into a place that is a little bit more difficult to get in and out of. It's not designed for continuous occupancy, so it doesn't have heating and ventilation systems and great lighting. Now, some of those can be included after the fact to make the work easier, especially depending upon the type of work being done. But in general, this is not something that people are going to be working in on a regular basis and staying in there for long periods of time. The provision for emergency response services is compromised. So again, is it easy for response agencies to get people in and out? And this is not only internal response teams, but external response teams. If there's challenges for that, it's likely meets this kind of definition of an enclosed or confined space. And then it contains a hazard which may pose an illness or injury. Now, there are a lot of differences around the world of what that means. Some countries focus specifically on respiratory hazards. Others focus both on physical and respiratory hazards as well, biological. So again, we need to think about, in general, how do we protect our worker? And that's one of the things that when we talk about the regulations in a little bit, for the most part, I don't care about regulation. I mean, it's important that we comply to them, but what's important is we try to make the space safe for our employees to enter and exit from. Now, and I don't get bogged down on the U.S. statistic alone. It's one of the things when it comes to confined spaces or enclosed spaces. And I've been again doing this for quite a few years and trying to do research globally when it comes to the amounts of incidents that happen. And most countries don't get into the finite details of confined spaces. And even the U.S. data is difficult to obtain sometimes because when we document a injury or an illness or a fatality, it's the type of work being done, not necessarily where it's being conducted at. So digging into this detail is a little bit more difficult. But when we looked at the data, and again, these for the most part, you look at other countries. In the U.S., 148 people died in confined spaces in 2018. And I know that doesn't seem like a lot when you compare it to potentially falls from height. David had talked to you, and the 3M team has talked to you about the number of people that die as a result of falls from heights. But still, any single injury or any single loss of life is important to try to prevent from happening again. In general, and again, these percentages kind of play out pretty similarly across the world of those that I've found, is that 61% of those people that die are a result of the physical hazards in the space. And it's falling into the space that can happen. It's things being dropped into the confined space. It's the equipment not shut off and an auger running, unfortunately, inside that space, or some type of equipment being running that causes the fatality. And then there are those atmospheric conditions, and we usually try to do a great job, and we do a great job in helping and improving the air quality in the space, but sometimes we just don't do it enough, and we'll talk about that in a little bit here. The interesting thing is that when we look at the other risk, and one of the things, and I know we get better globally in understanding hazards and protecting the workers, but when incidents do happen in those spaces, and when one person goes down, unfortunately, what happens is the next person goes down and another person goes down. And when we look at incidents we look at incidents that occurred in confined spaces where more than one person dies in that space, 60% of those are the would-be rescuers or people going in to protect them. And I think globally across the world, we can really look at the agricultural industry to see this happening, where somebody goes into some type of silo, a manure pit, or anything that can potentially contain or hold gases. Someone goes down. It's a family member that's going in to try to do the rescue, and that next person goes down. So we're seeing that happen, unfortunately, around the world where would-be rescuers go in. And one of the reasons why I highlight this statistic is because it really shows the importance of planning and being prepared to prevent that from happening. And so we want to try to prevent anyone from succumbing to the hazards within a confined space, but definitely we don't want to happen to more than one person just because we didn't have equipment set up ahead of time. So who goes into the confined spaces or enclosed spaces? Typically, in the data here, at one time, this data was, and again, it's an old data, but this was the justification that the U.S. used to basically apply the confined space law, 1910-146, which is the confined space law in the U.S. In 93, they justified it by saying there was 1.6 million people or workers entering 4.8 million confined spaces each year. Now that number is significantly higher today. However, we are finding ways, industry is finding ways, and it's something that I encourage you to do, is to find ways to potentially go into confined spaces without actually entering them. The use of drones are being used, installing cameras, removing equipment that would normally have to be entered, like valves in that, or to check gauges, move those outside of the space, which then prevents the need to go into them. But who's going in? It's typically the people that work for the employer. Your own employees may be going into the space, but oftentimes we have contractors do that, especially if equipment is being shut down during a turnaround of some kind, building overhaul or maintenance, or a couple of capital upgrades. It's going to be contractor workers that are going into those. And so we need to take into consideration even those people. And sometimes they're not as aware of the hazards in the space that your own employees would be. And so it's important to educate those people and make them aware of the potential hazards so that they don't succumb to the issues in the space. And then, of course, there are the rescue teams. As we mentioned, would-be rescuers. Fortunately, most rescue teams are a little bit better prepared, but some aren't. Confined spaces are not necessarily your typical response when it comes to emergency response teams. So again, and they may not be 100% familiar with your facility or the spaces within them. So a lot of people enter confined spaces or have the potential to enter confined spaces in your workspace. Now, why do they go into it? We mentioned this at the beginning. Some of it's as simple as inspecting. However, cleaning, environmental monitoring, doing repair work, which includes welding, maintenance, even constructing or building new confined spaces or new processes within your environment could be a confined space during the construction phase of the project. So there's a number of different things or a number of different reasons why we go into confined spaces or send people into them. Now, why do incidents occur? Incidents occur for all sorts of different reasons. And this is data that's being pulled from incidents around the world. And it's unfortunate, I see the top one right up above, confined spaces are not identified. The simple fact that there is differences in what is defined as a confined space. In some countries, some spaces are labeled. In the U.S., for instance, we label a confined space and it says permit confined space, non-permit confined space, and there's this perception that a non-permit confined space has no hazards. And in reality, that's not the case, and some countries don't even identify a space. And so it's people don't know that what they're entering is that, and then they don't understand the hazards. As I mentioned, contractors coming into your facility often don't know what the equipment is being used for, or what potential hazards might be present, from electrical to the physical to the biological or chemical hazards within it. I see so many times atmospheres are not tested, and you look at the would-be rescuers. Almost 90% of those would-be rescuers that died in it are atmospheric hazard incidents. And so they're going in and they're not testing the atmosphere. Confined spaces can be very complicated to get through and navigate. And sometimes you need to take a monitor with you, a gas detector with you, and not just rely on one outside the space. So again, I'm not going to go into give examples of each one, but you can see there are many different reasons why incidents occur. And for the most part, all of these are preventable if we put together a good safety and health plan ahead of time. As I mentioned, there are all sorts of different hazards associated with confined spaces. Some of them are pretty straightforward when you think about the physical hazards, from the stored energy. Even though we may have shut things down, there might be stored energy, noise, visibility, engulfments. There's a lot of confined spaces where people are consumed underneath material. electricity, the configuration hazards. It's just the space itself. These, all of our wonderful 3M marketing equipment makes it look so easy. We just lower somebody in a space and we pull them out of the space. In reality, we know that from shipbuilding to anything, that we sometimes get locations that we're entering, we're going in horizontally and then going vertically in the space, or so it's things aren't as simple and easy as we make them look in commercials and in advertisements, but there are those hazards that can create injuries or deaths within it. And then, as I mentioned, atmospheric hazards are there, but biological hazards are also there. There are from the simple things of bats and rats and mice to stray animals, snakes, in the spaces. And then because these don't necessarily get aerated in a lot of situations, not necessarily processed vessels, you can have the things as mold and fungi growing within that space that can create atmospheric hazards for the worker. So there are all sorts of different types of hazards in a confined space. And again, we need to be prepared to manage those to make it safer for our workers entering the spaces. We'll jump into regulations just ever so briefly, and again, they vary across the globe, but in general, the definitions pretty much stay the same. In the US, in reality, there's 3 big regulations: the general industry confined space, permit confined space standard that was established in 1993. There is the shipyards that was established in 1994. And then the most recent one was the one identified for the construction, which is 2015, 1926 subpart AA. The interesting thing for any of our listeners or our participants in the webinar in the United States, just because you may be in the general industry, because there are new requirements that are a little bit more aggressive, as it were, in 1926 subpart AA, and the moment you bring contractors on a site, you have responsibilities under the construction rule as well. So again, be aware of that you do have requirements, even though you're general industry, that are listed in 1926 subpart AA. Every country, I shouldn't say every country, most countries do have some additional requirements and regulations. From France, Germany, Ireland, and again, as I mentioned, the US, all have specific regulations. And where there are no specific confined space regulations, normal health and safety regulations do apply. The next slide, I think it's interesting, when we look at the regulations across the globe, it's just interesting to see that I believe Europe has it's a scarier but better approach, or seems to get things accomplished a little bit better. In the U.S., there's no significant no consequences when it comes to management and supervisors when it comes to safety violations and that. For the most part, the company gets a citation. Somebody might lose their job, but for the most part, again, I hate to say this, but it's just $1. And oftentimes, if they get a $10,000 fine, it can be, arbitrated, and now you're walking away with, a $500 fine. In Europe, those rules are different. There are consequences to management and management officials, company officials, that people can see prison time. And when there's that significant increase in accountability, I think that pushes down a little bit more to the rest of the organization to be a little bit more proactive and protect the workers a little bit differently. So a difference that I definitely seen. And there are a number of different countries that are beginning to add regulations that didn't previously have them. So be aware of your own individual locations. And of course, some companies do have their own company guidelines and policies as well that need to be followed, that are a little bit more restrictive to than the government regulations. All right, so who's all involved? There are a number of different roles, and again, this is more kind of a globalistic approach. And each country may have a little bit difference of roles and responsibilities, but it really starts with that competent person. And what we say here is that there has to be a person that understands the hazards, understands the unsafe and safe conditions within a particular environment. We talk about competent person in fall protection. The same thing generally applies when it comes to a competent person in confined spaces. And in general, they need to understand health hazards as well. So you need to understand the process a little bit. So you have to understand the work environment. You have to, so you understand which vessels. You have to be able to identify the vessel or the space and be able to identify whether or not it's a enclosed space, permit phase, non-permit, depending upon your rules, what type of space it is. You need to identify the different types of hazards. You have to identify how you're going to control those hazards. So a competent person isn't just somebody that comes in and just says, yep, that's a confined space. I'll give you a quick example. Back in 1994, when the confined space standard was established, I just finished, or I was in the process of finishing up my master's degree program, and I went and did an internship out into a company out in California. And one of the first things that they had me do was to identify all their confined spaces and start to put together their confined space permit program. You know, here, I mean, as a person that's working on my master's degree in safety and health, I was a firefighter at that time as well, an EMT as well. And yet, was I really competent? The answer is no. I mean, I didn't know anything about their process. I didn't know what kind of chemicals or what was being used in it. I had a general idea of what was by definition met the permit, non-permit. But in that particular case, even though I might have had a degree or in the process of getting one, it doesn't make me competent. So sometimes we need to get beyond just the safety and health or industrial hygiene persona and get more into the process understanding to really be that competent person, especially when it comes to confined spaces. When it comes to a very important role is that entry supervisor. And again, basically what we're saying here is the person that's authorizing the entry. Who's going to be there? And again, they have to have an understanding of those hazards. They need to be able to understand how long a person can work into that space because of either the environmental conditions, it's too hot, or the noise. How are they going to protect that worker? Hopefully that's been identified by surveys beforehand. They need to make sure that in the event anything goes wrong, that there is an emergency response that can take place, and they need to know how to get a hold of those people. They also need to make sure that people understand they need to stay away. I think it's very interesting, of all the confined spaces and the processes that I've been involved with, when a confined space gets opened up or a vessel gets opened up that's never been opened up before, it seems to attract people. People come in because they want to look inside the confined space. They want to stick their head in and see, because again, a process engineer, for all practical purposes, may have never seen what that looks like. They have drawings, they have 3D models of what it looks like, they have CAD drawings, but in reality, they've never actually physically been in it. And sometimes when we open up these spaces, it brings people to them, and that entry supervisor needs to make sure that those people stay away and don't go in if there's not a reason for them to specifically do it. And of course, they're the ones that are going to say, hey, when is this no longer advisable to enter? When is it unsafe? And they need to be able to suspend any activities that take place within the confined space. Another important role is the attendant. And, you know, I kind of talk about the attendant as a lifeguard at a pool or at a beach. They're responsible for keeping track of the people that are going in the water, or going in this particular case, going into the confined space. They need to keep an eye on those people, know how many people are going in there. They need to be able to let people know if conditions change, if a storm's coming at a beach, or a major thunderstorm and lightning's coming, get people out or let people know. The big difference with my analogy of the lifeguard and the attendant role is that in the attendant role in confined space, you don't enter. Okay, even when things go bad and somebody goes down, that attendant doesn't jump into the confined space like a lifeguard jumps into the pool or water. The role of the attendant is to stay outside the space, to manage the activities in the outside, monitor air quality, communicate with that person inside the space, make sure people don't come in or don't get come near the space or enter the space that aren't authorized to do so. They also need to, again, like I mentioned, pull people out if things go bad. And then hopefully, if we provided with them right piece of equipment, they're the ones that can perform that non-entry rescue. They're the ones that can turn that, pull that handle and turn that handle and pull that person out, or specifically activate the emergency response teams in the event that an entrant rescue has to take place. The other person involved here is our entrant. Of course, this is the kind of the main individual in our confined space. They're going in, they're doing the work. But they need to understand what the hazards are. Okay, they need to understand what's going wrong. They need to have good communication with that attendant. Sometimes they should be having their own gas detection as well. They need to be aware of, just like the attendant, they need to be aware of what kind of experiences am I going to have if I'm exposed to a chemical that might be present in the space? Am I beginning to get a headache? Am I going to feel nauseous? If anybody feels that way, they need to pull themselves out. And then in the event of an emergency, if the attendant calls and says, hey, need to get out, okay, they got to get out. They got to listen to that person. It's not one more turn of a bolt. It's not one more weld that can be done. You got to come out now. There are a number of incidents that have happened around the world where an entrant has died in a confined space, even though they've been told that that they need to come out because they just wanted to finish one more thing. They dropped something on the way out, turned back to go pick it up, and then succumbed to the incident within the space. So the entrant needs to be aware, pay attention, and get out when they need to do that. But obviously their main role is to do the work. But again, they can't do it with blinders on. They have to do it with the awareness that this is not a normal location to do it. They may be a welder every single day and weld every day, but when they weld inside a confined space, the welding in the confined space is significantly different than it would be if you're outside that space doing welding in open air. So your activities are different in a confined space. So let's jump into kind of that ABCs. We're getting into our ABCs of confined spaces. You can see them laid out here. In general, what we're talking about is the ABCs of confined spaces, very similar to that of the ABCs of fall protection. In general, when we're entering a confined space or an enclosed space, we want a few things. We want an anchor outside the space. We want body support. We want connectors, detection, and education. And they all play an important role, and I'm going to get into this a little bit more. In some countries, these are required specifically by law when entering a confined space. But in general, my belief is that this is best practice. Having this equipment set up ahead of time, regardless of whether or not it's required to by law, provides our workers extra protection. Because even if a space even if you're entering in a small space and you think it's easy to get in and out, if that person has a medical condition like a heart attack or a stroke, how are we going to get them out if they don't have some of this equipment available? So it goes beyond the law. It goes into best practice. When we don't have the right equipment, we increase the possibility of falling into that space. We expose more people to the hazards within the space because somebody might have to go in. It's likely someone's going to have to go in and do the entry rescue. It takes more time. It's very inefficient. And it also is very labor intensive because now we've got to, when rescue has to be done, we have to add equipment. When we have the right equipment in place, we have the right equipment that potentially has the ability to protect from falls. We oftentimes won't have to send somebody into the space because we can perform that non-entry rescue. The equipment's set up already, so it's much more efficient for time, and it exposes less people to the hazards. And it's much more labor. It's not as labor intensive because we're using mechanical advantages that are designed in the product to help us in pulling the person out of the space. So let's look at our A's. Our A's are our anchors. And let me just back up, for a moment and say there are many circumstances when we enter into a confined space, say a horizontal confined space, you're just entering in a tank and there's nothing in that tank, where some people will just simply put a rope on that worker, and that rope then is going to be that connector, which we'll get into. The anchor that we're referring to in those particular cases, we're tying off that end of that rope outside the space so that rope doesn't get dragged into the space. When the confined space gets a little bit more challenging, we may need to incorporate mechanical advantages. And so horizontal entries, like what I just said might be use a rope, our pull hoist, or our side entry systems may be able to give us that ability to add that mechanical advantage that a rope doesn't do. When it comes to vertical entry, oftentimes people think of the tripod as the primary piece of equipment for pulling somebody out of a vertical confined space. But sometimes that's not enough. And oftentimes confined spaces don't really work well for the environment because of the supporting structure, the entry configuration. It doesn't give us what we need to use. And so things like a davit system that allows potentially the ability to rotate anywhere from 90 degrees to 360 degrees to be able to pull that person up and out and rotate them away gives us the ability to give and protect not only the rescuer, but it also prevents that rescuer from being a victim within the space because things didn't go right. So again, there are more pieces of equipment out there than just your tripod to protect workers or to get people in and out of confined spaces vertically. And then again, the challenge that people typically, or the fact that people use a rope in entering horizontal confined spaces doesn't give you a mechanical advantage, and utilizing some type of system that allows you to put a winch or an SRL retrieval device on it gives you the ability to add mechanical advantages. When it comes to our B, or body support, typically, what we're referring to as a harness, okay? And oftentimes, if you were to do a web search on confined space harnesses, you're going to see these wonderful D-rings on the shoulders. They're great, and what they do is they help keep the body, facilitate an upright retrieval so that body stays more upright. They typically are going to have to be used with that Y lanyard that's sitting there. However, you're still suspending a worker from their harness, so there's still going to be the potential for suspension trauma if they're supported for too long a period of time. So sometimes we want to look at other methods to get people in and out of confined spaces. And oftentimes, especially if they're doing work that means that they have to be suspended over a period of time, we're going to want to put them on something like a Bosun chair or a suspended work chair, or maybe utilize a harness that we typically wouldn't think of, like a wind harness or an oil and gas harness that has built-in seats. So there are other options out there other than your typical harness. But generally speaking, a harness should be used in every entry into confined space. Even when we can't hook up a connector, as a rescuer, I want to see somebody in a harness, because when they have a harness on and I have to arrive on site and perform a rescue, if they have a harness on, I have the potential of doing a rescue without entering that space, because I can basically use a rescue pole, reach in and try to get them, and then use mechanical intervention to get them out. If they don't have a harness on, I have no choice as a rescuer, but I have to go in, because I can't just grab them by the cuff of their shirt and pull them out. Harnesses make a difference and help facilitate rescue, where not having a harness on makes rescue challenging for everyone. When it comes to our C, or a connector, these should be pre-rigged every single time. They should be on the tripod, on the davit system, on a pole hoist. What they do is they provide that mechanical advantage, and depending upon the device being used, they're designed for various mechanical advantages to pull people up or in and out. When there's a risk of falls, we want to use an SRL retrieval, so that allows for that fall protection, but then also allows the ability to protect the worker. It protects the worker from the fall, but it also is designed to pull that person out in the event of an emergency. And connectors can be challenging in understanding when do I use one over the other. And again, utilizing the support from a company like 3M, we can help give you some guidance in that. And again, rules around the world may vary depending upon where you are. So again, getting in contact with somebody that has a little bit of understanding about both fall protection, rescue, and retrieval will give you some really good guidance. But generally speaking, even if you have a confined space that has a ladder access, a person can fall off that ladder. You know, we need to protect that worker from fall protection, but also we have to be able to get that person out. So that device has to be designed, either an individual device or multiple devices to be able to perform those activities. Horizontal entries, as I mentioned before, seem simple. And again, we oftentimes rely just on a rope and a harness, but it provides no mechanical advantage. And so thinking about adding mechanical advantage is important. And there are spaces where there is no ladder, where we have to lower the person. And so having a lowering device and raising device, in addition to the need for other, maybe an SRL, depending upon how you're entering, may come into play. And again, it can be challenging, but when a company like 3M can support your activities, we'll get you in the right equipment to solve the issue for the problem, solve the problem with a particular option. All right, D is detection. Okay, there's a couple pieces of equipment that I think everybody should have when it comes to entering a confined space, and it really comes down to harness and gas detection. And again, depending upon the type of space, I also look at a rescue breathing system option as well. But most confined spaces and the fatalities and injuries that take into confined spaces, a lot of it can be resolved simply by detection. And what we're referring to is here, we need to be able to detect the hazards in the space. So understanding what hazards the employee can be exposed to, whether it's flammable or combustible, is there oxygen deficiency or toxic gases. Oftentimes I see so many times people use a 3-gas or a 4-gas analyzer to determine the quality of the air within the space. And it may not be sufficient enough, because if we're looking at an instance, for instance, a toluene as an example, and we're using just a 3-gas or 4-gas analyzer, we're relying on the LEL or the explosive limits to determine what our potential exposure is for toluene, and that is no way sufficient enough. By the time the alarm goes off for LEL, we more than likely have exposed. We have, in fact, exposed the worker to extreme levels of toluene that they should never have been exposed to. So we need to understand the hazards. And again, that goes back to that whole competent person responsibility to protect the workers. And then remember that things can change. You know, there may be residue in the space that wasn't picked up before until we started sloshing around in or moving around in it. So the disturbance of the sludge and deposits, the type of work we're doing inside the space, whether or not welding or painting, can change and add a new hazard that we weren't originally detecting or checking for. So we need to always be aware. This isn't confined spaces, that ever progressing hazard that changes based off of the work we're doing in the space, and where our detection has to be able to change and alter with that. We obviously need to have the competent person to be able to use the equipment. The equipment has to be calibrated and bump tested according to the manufacturer's guidelines. We should be keeping records of the activities and the readings, because one of the things about keeping good records, it also tells the next worker or the next time that piece of equipment gets shut down, what were the conditions in that space? Did the atmosphere change as of the type of the work we did? And if we didn't document that, you know, it's going to not help that next person. And then we really should be doing continuous monitoring. And as I mentioned before, sometimes that means adding a gas detection, giving a gas detector to the worker entering the space. Yes, monitor the space as the attendant, but give that worker that's going into the space their own, because oftentimes where the work is being done is far from the location where the attendant is actually monitoring the air quality. E is our education, and every person that's involved in the process needs to be trained, from that competent person to the supervisor, attendant, entrant, and the rescue team. Everybody needs to know their roles and responsibility. They all need to know the equipment that they're expected to use. They need to know how to use it. Training should be annually. I mean, we really should take a moment, and I love computer-based and web-based training, but when it comes down to it, having this web-based training doesn't show you how to use a tripod, doesn't show you how to connect the harness or make sure that harness is on properly. So training should be annually, and we really should be hands-on and utilizing the equipment that you're going to be expecting to use in the workplace. And we have to remember that it needs to be in a language that the employees understand. And I think in Europe, most of you get that better than in, say, the United States. Much of the workforce in the United States doesn't speak English as their primary language, and yet we still give most of our training in English. And in Europe and other parts of the world, it seems that you understand that better and make sure that the training for every employee is understood and people are getting in the language that they need to. F is our full body protection, and I know I hate lumping all this together, but in simplicity, rather than keep going down through my alphabet, this kind of worked out pretty good. It's everything else that we need to use to protect the worker, from coveralls to hearing protection to adding communication systems as part of it, because oftentimes hearing inside a confined space can be very challenging, so we need to provide some type of communication system as well. Breathing systems, sometimes we need to have an air supplied system. Sometimes that air supplied system has nothing to do with really protecting the air quality or protecting the worker from the air quality. Sometimes, and I made a recommendation to a customer in Saudi Arabia where they were performing work inside of the confined space, and it was incredibly hot in that. And adding an airline system that included a vortex cooler took that work, and where they were only allowing that worker to go into that space for 10 to 15 minutes at a time and then come out for a half-hour break. By adding that air cooling system or that breathing air system, again, no atmospheric hazards, but providing that air and providing a cooler air allowed them to stay into that space for a little bit longer period of time. I think they went from 15 minutes of work to an hour's worth of work before they switched out workers or took a break. So again, simple things can be utilized to help make it more convenient, more comfortable for the worker in this space as well. I mentioned this before. This is probably my third product of choice when it comes to confined space entry, especially when entries get complicated, is to consider giving each worker a emergency escape breathing device. Ours is referred to as the ELSA, but an EEBD is something that can be anywhere from 5 minutes to 15 minutes of air. If an alarm goes off, they can quickly put this on, put the cover over their head, turn on a valve, and in some circumstances it automatically activates, and then you start breathing air, and you have 5 to 15 minutes, depending on the cylinder size, to get yourself out. So less need for panic, more people can get out of the space. And again, it gets you the ability, as we get into rescue, to do that self-rescue rather than relying on somebody having to go into the space. So that kind of takes us to that confined space rescue planning. Confined space rescue planning is really about making sure that we're keeping our people safe and healthy. It does also protect our investments. It helps us comply with rules and regulations. And really, having a rescue plan in place gives us makes us better prepared in the event an emergency actually happens. How does planning start? It starts by what we talked about already, making sure your confined spaces are identified, make sure you understand the hazards within them, you're testing the environment with the appropriate equipment based on it. Everybody knows their roles and responsibilities. Everybody's getting training. We have the right PPE, and we have a way to call emergency response in the event that we need it. So that's all important and stuff that we've already talked about. But if we remember that rescue really should start out with that self-rescue. If we give the ability for that worker, and again, starts by understanding hazards, it starts with potentially giving that person with their own gas detection, making sure that everybody understands the hazard. So if they're starting to get that headache, they know, hey, I need to get out of here because a headache is something that could be an indicator that I'm being exposed to something. If they understand all that, they can get themselves out, self-rescue. When that's not an option, or for all practical purposes, we really should be considering non-entry rescue techniques. Having the tripod, having a davit system set up there ahead of time gives us the ability to do that non-entry rescue, allows that attendant to pull that person out rather than having to go in. And then the worst case scenario, and we understand that sometimes we will have to send entry rescue teams in, and they need to understand how to be able to perform that rescue. Whether it's an internal team or external response team, giving them the ability to practice a little bit is always important. So self-rescue, as I mentioned, is the safest and fastest way to provide rescue for confined spaces. And as I mentioned, we still want to have that non-entry rescue equipment available. Air monitoring is critical, and the thought process of having an EEBD for all attendants is important. For non-entry rescue, again, if each worker has a harness on and a retrieval line, that makes things easy, but they've got to at least have that harness on. But non-entry rescue really is about having our equipment set up ahead of time to be able to facilitate that rescue. Entry rescue, not necessarily our first choice at all, but we need to make sure that people, if we're relying on our internal rescue teams, that they are prepared to and have the appropriate equipment to provide that rescue. They need to have plans and they need to have procedures in place. When we're relying on off-site rescue teams, we need to make sure that they understand also the challenges that they're going to face and potentially give them the chance to get into that location. And they need to be familiar with what type of rescues are going to be done. The picture the drawing that you have off to your right here is something that one of the customers that I worked with in the shipbuilding industry, they had a number of fatalities. They had actually 3 fatalities within the bulkhead while building a ship. And what they did is they built a mock-up, and this is a drawing of the mock-up of that they had as a training tool. So a full-size mock-up that allowed the rescue teams, both internal and external, to be able to practice and not restrict the production as well. So an interesting thing that we need to think about: how are we going to train our people when it comes to entry in a rescue in confined spaces? So in summary, when it comes to rescue, again, we need to make sure that all our confined spaces are identified. We need to make sure that our workers are prepared for the tasks that they need to be done. We have to evaluate the confined space, complete a risk assessment, and sometimes that comes in the form of job safety analysis. Develop a safe system to perform that work. Identify the critical equipment that's going to be needed, from PPE to rescue equipment. Make sure everybody understands their roles and assign roles. Check training and make sure everybody is trained, and then perform the work under the appropriate permits if necessary. So we talked about a lot of stuff in a very short period of time. Again, probably not in as depth that I would love to. I could spend hours talking to you about confined spaces, but hopefully you understand that regardless of where we are in the world, confined spaces, especially in the steel industry, are present, and we have to send people into them. We understand, though, that there are specific regulations we need to find. However, it's important that everybody that's involved knows what their role is and their responsibilities. Provide our workers with the appropriate ABCs, and you can see that it's more than just tripods now, and then make sure that we have a good plan in place before we actually send people in, which includes rescue as well. So again, a lot of material in a short period of time. I really appreciate the roughly 50 minutes you gave to me, and at this point in time, I'm going to take a look and see what kind of questions that we might have that I can help answer.
Thank you, Stephen. It was a great presentation, a great overview of all the things that we need to do really to improve our defenses and to improve our controls in the steel industry. Yes, we have a few questions. So let me share with you the first one. It says, how do we handle multiple entries into a confined space? Do we need to have separate rescue and recovery for each operative?
Okay, yeah, it's a great question. So oftentimes, and most equipment that we have available is designed really for one person at a time. But we know that that's not necessarily the case. When we enter into confined space and do work, we're usually sending multiple people down in it. It really then comes. We need to think about performing that rescue. So again, I go back to kind of those basics again. When we enter into a confined space, we really should be thinking about, can we put a rescue line on each individual person? If that's not the case, we then, because that's at non-entry rescue, right? We need to think about, how do we then facilitate a self-rescue? So that's where EEBDs come into play. So that gives people time to get in and out of the space. But so again, it is a challenge. And again, I'm probably babbling on my own words here, but I've had situations where I've had 8 people in the same confined space with only one tripod and one entry point. It's managing that attendance responsibilities to manage all those people. We actually kept people connected to separate systems, but then it's managing to make sure people aren't getting tangled up. But in reality, only one person can come out at a time. So we need to give people more time. So when it comes to multiple people, we need to give them more time while they're in that space, and then utilize that one. There are situations where we've seen multiple rescue systems set up, so 2 or 3 Davit arm systems set up, but in some circumstances, when you only have one entry point, there's not a lot you can do.
Okay. Thank you, Stephen. I think one of the questions was related to horizontal rescue, so horizontal arrangement, and I think it makes sense because in the industry, I think in general we have a lot of confined spaces that are horizontal. We have silos, we have containers, we have a lot of things. That are horizontal, or a combination of both horizontal and vertical. So would you give some advice about for example, how we can combine or arrange the solutions for this vertical and horizontal?
Absolutely. Again, our product availability is a little bit different from each country that we have. So some products are available, some aren't. But in general, we do have a couple products that are designed that allow for that mechanical advantage, so you can pull somebody out a little bit better. The other thing is, we do have a product, again, depending upon what country you're in, that allows for, if the vessel's strong enough on the outside, or if we have a strong enough anchor point on the floor, we can actually have an arm that reaches into the confined space that allows for horizontal retrieval, but it also protects the worker from vertical lifts as well, or falls within that confined space. So there are some options there. But in general, we need to make sure that that person is wearing a harness that will help facilitate that entry and exit. And then we think about that transition in and out of the confined space. Oftentimes, and I've done this as part of my rescue team, we're a little innovative in ourselves. If you take a look at some of the children's outdoor play sets, oftentimes they have a slide on it. We've actually taken, as part of our rescue team at 3M, we actually took a section of that slide and cut it smaller. And what that allowed us to do is that we use that kind of as a lip on the internal of the confined space. So some of them, you have a silo that you enter. Well, if you're pulling a worker over to the edge of the confined space to get them out, they kind of get stuck right at that edge. By inserting that little slide there, we were able to allow them to actually slide them up that slide to get them and make it easier to pull them out. So sometimes it's just about thinking about or practicing to determine your best options. And oftentimes, as I mentioned, it's not necessarily utilizing that stuff that 3M is going to sell. It's utilizing stuff that you might have in your own background or backyard.
Yeah, that's right. Yeah. Thank you, Stephen. Then we have another one that is related with the gas detection. So it says, I think it's a basic one. Do we always have to use gas detection or air monitoring in a confined space?
And my answer would be yes. With the number of fatalities that take place in confined spaces globally, we really should be checking our air quality. Understand what what potential, I mean, at a minimum, we're looking at oxygen levels, right? And carbon monoxide levels, but then they were typically LEL in a lot of circumstances, maybe not so much in the steel industry, but H2S. We look at what type of hazards or other chemicals that you're using to make sure that you're using the right gas detection. But I would, without a doubt, say that we should be checking our air quality before entering any space that's enclosed or confined.
Okay, and I think one that is related to what you just said is that if you know, maybe not now, but maybe we can share it later, if there is any standard for air exchange or flow rate of fresh and cooled air, considering the volume of the confined space.
Yeah, there are some countries have specific requirements and give guidance on how much air exchange needs to be taking place. So, and it's a really good point. Most employers don't even take that into consideration. What they do is they open up this space, they put an air mover in there and call it good. They don't actually, have never done a calculation to determine what exchange rate they actually need. And by simply putting that blower there, do they have what they need? Or should they have an elephant trunk or something going deeper into the space? Should they have an opening at the top to be able to filter the air through the space? So most people don't take that in consideration, and they really should. We should be doing a calculation based off the size and air exchange based off of the vent system that we have. Again, some countries have specific exchange rates and others do not.
Okay. I guess in the US you can find that in the OSHA regulation, right?
Yeah, so there's some of it in OSHA. Otherwise, we're using best practices, and even NFPA gives some guidance on that, as well as ANSI.
Yeah, yeah, that's right. Okay, maybe we can answer one more. It says,
Okay.
what is your opinion on rope rescue systems?
Okay. So again, I'll gladly share opinions. Rope rescue systems are awesome. Okay, that's how I started. I mean, when I started on the rescue from heights and confined spaces, it was all technical rope rescue. That was over 30 years ago. Within that time frame, I have not. I mean, having rope or using rope rescue and utilizing a team that performs rope rescue means that you need to have dedicated people that spend lots of time practicing and honing their skills. I probably knew, 20 different knots at one time. I don't remember those 20 different knots now. I try to keep things, and I mentioned earlier, as simple as I possibly can, because ropes become challenging. When you try to create a 3-to-1 or a 4-to-1 or a 5-to-1 mechanical advantage, and again, you just think about that. If you're just using ropes and pulleys and you want to create a 5-to-1 mechanical advantage, and you have to go 100 feet into a space, you're talking 500 feet, 600 feet of rope. You can get the same mechanical advantage or better from a cabled system like one of our winch systems, a lot easier, and people don't have to remember how to tie a knot, how to put a Z-rig on a system. So if you are going to rely on rope systems, that's fine. Just make sure that your people have plenty of time to practice and you have the right equipment based off of the exposures and needs within your facility.
Okay, thank you, Stephen. Let me just look at, because we got the questions through the chat, so I'm just reading.
Yep, and if we obviously if there's that many questions, which is great, we can capture those questions, and I'm not sure if there's a way for us to get back to them or post any of the answers, but I'd be willing to answer any questions or provide my my contact information to follow up with anybody if they need anything.
Yes, everybody that is registered to the webinar will receive a notification when the recording is available together with the
Great.
presentation, and also I think David also shared his email in the chat.
Wonderful.
So they can contact all of you to really make progress or follow up with all these questions about gas detection and the mechanical devices that I think are very important to understand and find the good solution that we can implement in the sites.
Okay, great.
So once again, Stephen, thank you very much. We at Work Steel, we appreciate your support, your help. It's always great to have the specialists with us and sharing knowledge. And I think it's very important that we also share the applications and solutions. So appreciate your effort and your time
Thank
today.
you, Carlos.
And for the rest, thank you very much also for joining. I hope you found this webinar interesting and also useful. There are some contacts now in the chat. I think Stephen just shared with us his email. So please feel free to write to them directly or write to me if you have my email as well, and we can follow up everything. Uh, Thank you, everybody, and see you next time in the next webinar.